Hey guys, welcome back to my channel Zenkayya. I am here back with another video. So I am loving the responses that you are giving, full of love, but I have one complaint with you guys, that is you guys are watching the video but you are not subscribing. So do this small favor that subscribe it. Like, it takes a lot of effort to make this video, to make this quality content, as because it takes time and effort. Alright, everything we do in our life takes time and effort. So I'll be motivated to work more towards it, to make more quality content for you guys. Alright, so it all depends on the responses. So let's keep a target of 1000 subscribers in this video, so that let me see whether you are responding or not. Okay, so 1000 subscriber for the next videos. Alright, with that, let's start today's topic, that is TCP protocol. Alright, so in the last video we have seen the OSI model, how it works, what is the actual process. But then again I told you that the most important thing is OSI is a conceptual, it is not in real world. Okay, it is not a real world implementation. Okay, what is real world implementation? It is TCP IP protocol. There are 4 layers, okay, that I have already told you in the last class. So in this today's, how TCP IP model works, that we will see today. Okay, again, do not confuse with two things, TCP IP model and TCP protocol. Many people are confused with TCP protocol and TCP IP protocol model. TCP IP is a model, TCP is a protocol. Do not confuse. Okay, TCP IP is a model, 4 layers model on which the whole internet is working. TCP is just a protocol on which the connection happens, the reliable connection happens. Okay, so there are 2 important protocol that is there, that is TCP and UDP. In short, TCP, wherever you need a full data integrity is required, there TCP is being used. And next is whenever you don't require a data integrity, that time the UDP you are using. Okay, you are not using, the whole network is being using the protocol. Alright, with that, let's start. So first is TCP protocol, the three-way handshake. What is the three-way handshake? There's a term called three-way handshake. A lot of times you might have heard, but let's understand today what exactly is three-way handshake and how it works. Okay, so connection oriented three-way handshake, and TCP ensures a reliable connection before sending data. Imagine A is there, B is there. So if A wants to send message to B, A will make sure that B is having stable connection, then only A will send, otherwise A will not send. Okay, that is done by TCP. You are not doing that again. Whenever you are sending message, TCP protocol is being used in the networking analogy. Okay, whole networking concepts, TCP protocol is being used. Okay, next, so let's see advantage of TCP and disadvantage of TCP. So the first one, so here do not again confuse, that is TCP IP model, this is protocol. Okay, these are 2 different things. So advantage and disadvantage. Advantage of TCP guarantees data integrity. As I told you, if you are sending one message, let's say you are sending I love you to your girlfriend, then you want to send the whole I love you. Imagine you are just I love is going, but you is not stuck somewhere in between. Would you like it? No, you wouldn't like it, right? So you would like to send the full message to your girlfriend. That is, in this scenario, TCP will surely help you. Alright, so advantage of TCP, guarantees data integrity. Next is maintains order of packets. In TCP there is something called sequence number. So while we have seen in the OSI model, it breaks into different packet segments. So all those different segments will have a different sequence number. So imagine a long message is there, I am slicing it into 4 parts and I am naming it as 1, 2, 3, 4. Okay, as simple as that, so that it can go sequentially. It will follow a sequence through which it will set up a connection. Next is prevents data floods. What does it mean? It means that whenever all the data is going at once in that particular server, the receiver server, it creates floods, right? So it avoids that. How it avoids? It will send one by one, sequentially it will send, so that data flood will not occur. Okay, as simple as that. Next is disadvantage of TCP. What are the disadvantage of TCP? Let's see it. Slower due to reliability checks. Obviously, imagine you are going in a airport security, so it will be obviously slower. Why? Because lot of checks are there. That is here slower due to reliability checks, because connections need to be built before sending one message to your friend. Next is requires stable connection. Obviously, without stable connection it will not send at all, right? Can bottleneck during poor performance. Bottleneck in the sense the head of the bottle is quite smaller than the other parts, so if your connection is little slower, it will stuck there, so it will create it will create a traffic in that particular neck area, so that is known as bottleneck during poor performance. Okay, I hope you have understood. These are the advantage and disadvantage of TCP protocol. This is very important. A packet will be there, in that TCP protocol will implement its protocol, right? It have to follow the rule, that packet. So what it will do, it will follow some headers needs to be there. What are the header? First is source port and destination port. We have already seen ports. Ports are logical gates through which the communication occur. So source have to set its source port, that is random port of sender. You can see any random port of sender it can choose. Destination port, fixed port of receiver. So if you are sending it in a web server, it will choose the 80 port, because it is going through that fixed port of receiver. Destination port, source IP, the sender's address. Destination IP, the receiver's IP address. Okay, it is required. Sequence number, whichever packets are going, it will require which sequence number is it. Is it 1, 2, 3 or like that? It have to follow the sequence number. Acknowledgement, whether is it confirming, is it received, is it have I received, am I sending it back? So acknowledgement is required here. Okay, without acknowledgement it will not proceed further. Next is checksum. Checksum means, imagine I have sent all the data to this server, and then again it will check whether all the data has been sent or not. Alright, that is how it checks the integrity. It is called checksum. Alright, next is data. So the actual data is also being attached in this particular TCP packets. And last one is flag. Some flags will be there, for example SYN-ACK, FIN, REST. All these are different flags that implements different protocols. Okay, that implements different concepts. We'll see that flag in the next slides. So I hope this is clear. You make sure take a screenshot or note it down. These are very important in networking concepts. This is the basic fundamental of how networking works, how the internet works. Okay, without this internet is not possible. So you need to understand how it works. Next is three-way handshake, how it works. So how it creates the three-way handshake. So first A is there, B is there. First A will send, let's say hi. Hi, are you there? A has sent. B will say yes, I am there. Then A will send okay, I got it. Okay, so three-way handshake. First I am telling hey, are you there? Second B is telling yes, I am there. So it is sending yes, I am there. And again you are sending what? Okay, got it. Okay, so three-way handshake. SYN-ACK and acknowledgement. Client initiates connection, that is hey, are you there? SYN acknowledgement is server acknowledge and agrees to connect, and acknowledgement is client confirms connection is ready. So now I can send the data. So now actual data will be sent. Actual data transfer begins here in this. And last is FIN. FIN means when it's done, when I have sent all the data, then I have to send the FIN flag. I already told you FIN flag is there. I'll tell how it initialize the FIN also, but for now just understand FIN is a flag. RST is also a flag. When you send RST, when it termination, some kind of error happens during the connection, then RST flag will be sent. Okay, these are some flags that are required. So you can see the diagram here. Client is there, server is there. First SYN will be going, next SYN-ACK will come, and last SYN will be again going. So there's a three-way handshake. That is the reason it is called three-way handshake. Okay, I hope you are understanding it. Next, look at this way. Example, starting with sequence 0. So this A is sending 0 and this SYN-ACK is sending 5000. Okay, 5000, it is initializing with 0, it is initializing with 5000, and it will tell I have got your 0. So next, again client will send 1 this time. Why 1? Because the last time it has sent 0, this time it has to send 1. So that is how it is checking. Okay, last time it has checked send 0, this time it is sending 1, so it is sequence is correct. So that is how the connection is proceed. Once it is done, then it will proceed with the main data connection part. After that it will finish the connection. So observe here, once the data is sent, after that how the fin works. So again it have to send fin. So it is not like data is sent, now you have to stop the connection. No, directly it does not stop. It again stops with three-way handshake. How? First it will send fin, I am done, this is my final. Again it will acknowledge, and it will also send fin, and again last it will also acknowledge that okay, I have got your message, goodbye. Alright, that is how three-way handshake works. I hope you are clear with it. Very easy. Next one is UDP protocol. I already told you that when this UDP protocol happens, usually when it is not, it is not guaranteed that you will get that particular data or not. For example, video call, for example, playing a game, for example, calling. When you do all those things, it is not guaranteed that you can do video call at any place at any time. No, because it depends on network. So all those scenarios, UDP protocol will be used. So it is also known as stateless communication. No need for a continuous connection. Alright, sometimes it will work, sometimes it does not work, so accordingly it will send data between devices. No three-way handshakes or synchronization, no sequence is there, as there will be packets will not be divided into sequence. No three-way handshakes are required, as because no, this is stateless communication. Last one is usage, ideal for application that can tolerate some data loss. Example, video streaming, voice chat. I have already explained you. Suitable for unstable or unreliable connection, where it is not guaranteed. Okay, advantage, faster due to minimal overhead. It is faster. Why? Because it does not create any three-way handshake and all. It directly sends whatever you want to send, right? That is why it is faster. Lower latency, as of no connection setup is required. Obviously lower latency. Okay, you cannot expect the full latency, full clarity, let's say. Okay, so that is how lower latency, you cannot expect the higher latency. UDP disadvantage, no guarantee of delivery. When you are doing video call, there is no guarantee that it will create a connection. Why? Because it goes on UDP. Okay, data can be lost or received out of order. So while doing streaming and all, sometimes it can hang, sometimes it can error can occur. All right, so that is the part of UDP protocol, so you cannot complain. All right, so look at the header. Just like TCP header, UDP header is also there. So there are here one big difference is here no sequence number is there, no acknowledgement is there. All right, that is the main part of TCP. Acknowledge, it will acknowledge and it will set a sequence number. So here time to live is there, means it is not forever. Expiry time is there. So whenever you are sending something in video call, there is some expiry time. If that time is exceeded, it will be expired. Okay, you cannot send anymore. So time to live is there. Next is source address is there. Destination address will be required, obviously, right? It is IP address. Next, port is required. Source port and destination port is required. Data is obviously whatever you are sending, data is required, right? So look at the diagram. It is quite simple. Request is sent and response is sent just after the request. It is not checking any of the acknowledgement, it is not checking any of the handshakes, right? It is directly sending. So with this we are done with three-way handshake. It is quite an easy topic, and this much, if you understand, this much is enough. You don't need to go more in depth, it is not required. Okay, so I hope you have enjoyed it, and remember the target is 1000, and I'm hoping that you guys will help me out in that, and I promise you that I will deliver the quality content like this. I just need your support. Okay, keep supporting me. That's it. We'll meet you in the next video. Thank you.